round 4. So we have 4 teams here. We have Team Kazakhstan as reporter, Team Taiwan as opponent, and Team Hungary as reviewers, and Team Czech Republic as observers. We have the jury here. It's nice to see you all here. Let's start with the introduction of teams. So, teams from the order from right to left, please start introducing yourself.
Hi everyone, I'm the captain from Team Taiwan. You can call me John. And this is Kai, this is Justin, this is Andrew, and this is Oscar. And we hope to have a great fight with you guys. Thank you.
Hello, my name is Kai. I'm team captain of Team Taiwan. Here sitting here, Sonali, Azamat, and Yurga. We are wishing everyone good fights.
So welcome everyone, we are Team Hungary. Our team members are András, Blanka, Stella, Laci. My name is Milan, and we also have our two mascots, Bis and Bas. We wish everyone a pleasant fight.
Thank you.
Hello, we are from Czechia. I'm the team captain. My name is Luca. This is Michael, Krzysztof, Dan, and Dan. And we wish everyone good luck.
Thank you. Let's introduce our 5 attendants. So, and thanks them for being in on this fight, helping us. Let's see if you want to introduce yourself. And now we can introduce the jury. Yes, from right to left.
Okay. My name is Ottmar Winkler. I'm from Germany, high school teacher there. It's my first time at an IYPT jury, but I have been involved in the IYPT since 2012. Thank you.
Hi, I'm Shashikant Pandey from India. I'm a high school teacher teaching physics and maths. I'm associated with IYPT since 2017. I'm teaching ISC physics and maths since 2003. Thank you.
Thank you.
Wish you all the best.
Hello everyone, my name is Miloš. I'm a master student from Slovakia. I'm a former IYPT participant and also former team leader. I wish you a very good day.
Thank you.
Well, hello everybody, my name is Luis, I'm from Brazil, I'm a teacher. I was a juror in the IYPT and this is my first time as a juror here in the IYPT. Good luck.
Hello everyone, I'm Georgi Homeriki from Georgia. I've been a participant in 2016. Now I'm in Simon, and yeah, I'm looking forward to a great physics fight. Thank you. So, before we move on to challenge procedures, since this is round 4, I want to remind you of some regulations. So, first of all, what I would like to ask you is that after the challenge is accepted, like within 2 minutes, please write down the names of reporter, opponent, and reviewer on the whiteboard. About the regulations, what you have to keep in mind. Each person is not permitted to present a problem more than 3 times. So a reporter from the same team cannot present it 4 times. I don't think that we have such case, but just keep in mind. Second is that we have the schedule, and it is said from the past data, the problems that you can challenge, the opponent can challenge the reporter. So naturally, like you rejected problems reported by reporter or posed by opponent and reported by opponent cannot be challenged on. This is a list that the team Taiwan can challenge Kazakhstan on for the first round. However, if there are less than 5, so it means 4 problems remaining, I will be lifting the ban. So if that happens, then I will go to the whiteboard and write some additional numbers. Also, keep in mind that some teams have many rejections, some teams have low rejections, it depends on strategy. I'm not here to discuss that, but keep in mind, it's very important that you cannot reject more than 8 problems. So like if you have 8 rejections and the next challenge like should be automatically accepted. So like please keep that in mind as well. I do not believe that I have missed anything. Hopefully not. So please just to be prompt and not to have delays. Please check right now. I'll give you 1 minute to check all the cable connections and turn off the internet connections. Yeah. And so just check if so this screen will be for the reporter and the reviewer. Check that if everything is working.
Yeah, we have to check this.
Perfect. Yeah, Kazakhstan is it working?
Yeah, we're
Yes.
Perfect. And for Team Taiwan, we'll have this screen and that screen if I'm correct. Yeah. So so that the reviewer can see from here. And the clock will be there for everyone. And yeah, let's move on. If everyone is ready, we can start the challenge procedure.
I'd like to challenge problem number 12, sound versus fire.
We accept the challenge.
Problem number 12, sound versus fire has been accepted. You have 5 minutes to prepare. You can start whenever you want. But make sure that the presentation runs well because there is a tight run. doesn't So if maybe it has IYPT assistance, but this may show. Do you have some extra papers? Ah, thank you. You can just use some of the
Hello, my name is Asanalita Stan, and today I'm going to be presenting the problem 12, sound versus fire for Team Kazakhstan. So, let's read the problem first. A small flame can be put out by sound. Investigate the parameters of the flame and the characteristics of the sound that determine whether the flame will be extinguished. So, we investigated the sound and its sources. First of all, some sound characteristics that we investigated were the frequency of the sound wave, the amplitude of the sound wave, and finally the distance between the sound source and the candle. And the sound sources that we used are going to be a mobile generator app and a speaker. So we also investigated the burning candle mechanism with a paraffin wax candle. So first of all, due to the burning of the wick, the paraffin melts at a temperature of around 50 degrees Celsius. And because of the capillary effect, the liquid paraffin actually rises of the wick, and because of the high temperature, the liquid paraffin then evaporates. And because of the convective currents, the gaseous paraffin is going to rise towards the flame. So finally, the paraffin melts with oxygen, which creates a chemical reaction. We can call combustion. So we also investigate the fire characteristics because the candle power is a direct flame parameter that depends on a large number of other parameters of the entire system, such as the length of the wick, the candle diameter, and the wick diameter. So we established a small equation where n is equal to lambda divided by delta mass divided by delta T. N is going to represent our candle power. Lambda is the specific latent heat of combustion. Delta mass and delta T, we experimentally measure how much paraffin burns in this fixed period amount of time. So we then plotted a small graph with in the x-axis we had our power in watts and the flame length in centimeters on the y-axis. And as we can see, as we were increasing our power, our flame length was also increasing. So what can we say from this? That means the candle power could determine the average value of the convection flow, which we named vector 1 as V1. So we then studied some significant dependencies on the power. So we had our wick length, and we saw that as we were increasing the wick length, our power was decreasing. However, as we were increasing our candle diameter, our power was increasing. So we then studied the candle behavior at some different frequencies, and we saw that about from 5 to 20 hertz, we had some symmetrical oscillations. From 20 to 50 hertz, we had oscillations with a significant slope. From 50 to 100 hertz, we had the phenomenon of candle extinguishing. And from 150 to 300 hertz, we had oscillations with a significant slope. And from 300 hertz, there were actually no effects on the candle whatsoever. We studied the system behavior at frequencies less than 20 hertz, and the speed of sound in our environment was actually around 340 meters per second with a frequency of 20 hertz. And with this equation, we can find that our wavelength was actually around 17 meters. And our candle attenuation could not be experimentally observed in this frequency range. So then we conducted a small experiment of system behavior at frequencies greater than 20 Hertz. We first played a candle, and we can see that it had an effect on the candle. However, when we put a disc in front of our speaker, the flame actually stopped deflecting due to the lack of an external flow. So what can we say from this is that the wind from the speaker that it is the wind from the speaker that causes the candle flame to fade at frequencies above 200 Hertz, 20 Hertz, sorry. So then we studied how we could actually calculate this deflection angle. So we had two main vectors, V1, which is the velocity of the convection flow that we studied in the first slide, and V2 is the velocity of the external flow, which is actually the flow that is produced from our speaker. So with this, we can study the angle, which we name as theta with the arc angle. So then we actually wanted to provide some evidences of the existence of the airflow. So first of all, we used the Schlieren method, and we could see that there were air particles replacing, so in our case it is the sound. Then we used an anemometer to show how our wind current is produced. And finally, we used the smoke machine. So what did we deduce? We deduced that there is indeed an airflow that, from the speaker of the phone, and it is going to be the reason of its fire extinguishing. So why does this airflow actually arise? So the air expansion of the membrane from our sound source actually creates a wave pressure, and it goes from the speaker to the limited space that we noted as S1. However, during the next oscillation, the diaphragm compresses and it sends back the pressure over a larger area, which we named as P2. So in our case, we have that S2 is obviously superior to S1, and V1 is going to be superior to V2. So there is an asymmetry of the system. So what does this mean? That means the amplitude of the sound plays a positive role in extinguishing the fire. So the flame is deflected to one side at a greater angle. So then we plotted graphs of the sound volume and the confirmation of our theory. And we could see in our graphs that as we were increasing the volume in decibels, that our deflection angle was also proportionally increasing. So we could say from this that the higher the sound volume was, the greater the flame deflection angle was. So then we further studied the effect of the frequency on flame attenuation. So we saw how the candle acted depending on different frequencies. And what could we say from here? We could say that the dependence of the flame slope on the frequency is not monotonous, and I'm going to show why. So we traced the graph with our frequency on the x-axis and the deflection angle in the y-axis. So what could we find? We found that our candle could only extinguish at this green area that we noted over here. So it is when the flame deflection angle is equal or superior to 90 degrees. So then we studied how the sound frequency actually varied depending on the volume varied on depending on the sound frequency in hertz. So we could see that in different with different frequencies we had different sound volumes. So then we plotted a small deviation map. So we plotted an x-axis and a y-axis, and we could see that in these red areas. This actually meant that the flame deflection angle was actually quite high, and it was going toward the other side of the speaker. However, when it is blue, that means it is going towards the speaker, the flame deflection angle. So then we did the prediction of our flame extinction. So we needed to study our airflow velocity, and that was our main aim. So we had our parameters, the initial velocity and our surface. So with the following formula, we were actually able to find the average velocity of the flow for the period. And we used this equation because it was absolutely necessary to predict the initial velocity at every single point of the flow. And for our study, just to say, we took the candle power as a constant. So we later modeled our situation in the console. So we could see that there are areas of high and low pressure around the speaker. So the red areas actually showed the high amounts of pressure, and blue showed low amounts of pressure. So with this modeling, we were actually able to obtain a velocity field and a pressure field at each point of our speaker. So then we actually compared our speaker modeling with our actual experiment, and we actually took a constant of frequency which was equal to 600 hertz. So our average velocity in the experiment was around 4.5 meters per second. However, when we modeled in COMSOL, there was actually we averaged the speed value over the selected distance, and we found that our average velocity was actually equal to around 5.3 meters per second. So we could say that there was a small difference because in our experiment, our frequency was actually also produced in an amplitude, and this actually affected our experiment as well. By the way, I have to say that the average velocity that we found for the modeling in COMSOL was actually the closest value to our experiment. So what have we achieved in this task? First of all, we examined the parameters of flame and sound. We provided and studied the cause of flow in the system. Then we studied the different modes of candle fluctuations. And finally, we examined the several sound sources and compared the results. So this is all for the report of Kazakhstan for the 12th problem, sound versus fire. Thank you for your attention, and I'm looking forward to your answers.
Thank you for a great report. So I have a question about your experiment control. So you said the fire volume depends on the wavelength, correct?
Yeah, sorry.
The wavelength.
Yes, okay.
So over time, the wavelength will go up, go down. So would the intensity of fire change over time?
No, I was saying that actually the wick length was increasing. It was increasing, so.
So will the fire volume change over time? The fire intensity?
Yes, it would be.
Okay. So you said you modeled the tilting of a fire. So did you have any graphs of the angle over time?
No, we don't have this graph, but we studied this.
And is there any patterns of its angles?
For what exactly? For the frequency?
Okay, we can leave that to a discussion. So when you change the sound frequency for a speaker, did you also adjust the sound amplitude?
No, we took a constant amplitude.
Okay, thank you. So for a three component of fire, fuel, heat, oxygen, which part of you think which is missing if you want to make the fire extinguish?
I think if oxygen, could you repeat the question, please?
Fuel, heat, or oxygen?
Yes.
Which one is missing if you want the fire to extinguish?
If you want the fire, it would be the cooling that would be missing.
The what?
The cooling.
The heat?
Yes.
Okay. Do you measure the sound profile of your speaker? Do you assume the speaker's profile being uniform? So the middle of the speaker and the side of the speaker, does it have the same sound?
No, it wouldn't have the same sound, no.
But you always put the candle in the middle, correct?
No, yes, but we also did the deviation map where we put the candle in different positions as well.
Okay, and a final answer please. So what is the difference between sound and wind?
Sound and wind?
Yes.
The wind is what actually extinguished our fire, and sound is just the waves that were produced.
Okay, thank you very much.
Thank you. So remain preparation time. 1 minute remaining. Seconds. Start. Timer.
Okay, hello everyone, I'm an opponent from Team Taiwan opposing problem number 12, sound versus fire. So here's the problem statement, and I would like to share my key question of this problem statement I think. So the first important thing is the difference between the wind and sound. Because the reporter in his report mentioned the wind from the speaker is the most important, but why would this problem called sound? Why is sound very important? And then why does the tilting and the shifting of the flame causing extinguish? Where I think the reporter mentioned he had measured the angle, but I think it's a good measurement, but I would like to see the angle over time. Then the characteristic of a sound. So it's for the amplitude and frequency, where I believe the reporter both did experimentally, which is quite good. But I think there's also some complex tones to be investigated, which cause some interesting results. And finally, the optimal extinguish parameters on which parameters need to balance out to find an optimal extinguish. So here's a quick review of the report. So for phenomenon, the report says the flame length will depend on the candle power, and the flame will have some tilting and shifting motion. Then he also find the extinguished range, and then talk about the components of fire and the natural convection. Then I think he catch the important part of the extinguish process on the flame's motion, which I think his videos are clear. And then also he also showed the key motion to extinguish, which he thinks is wind. And also he explained how the flame works. But I think the room for improvement is to explain what is the main difference between wind and sound. And then also, I think to talk about extinguish, the three elements of combustion is very important, which is the fuel, heat, or oxygen. Then for the theory model, he assumed the sound using an average airflow, where he used console to stimulate the speaker, which is around 20% error. And in a short question, I asked the reporter, he said the extinguish is due to the heat missing, which I kind of disagree on that, which I think the other two properties of the fuel and oxygen are the actual reasoning, so I would like to discuss with that later. But I think he has a good modeling on the actual airflow, and I think, yeah, and let's go on to our experiments. So his setup has a speaker and a candle, and for the sound, he changed the frequency and amplitude. And the other parameters, which is the length and diameter of the wick and candle diameter. For his model, I think he assumed the length of the top of the candle is constant, but I believe over time it will keep burning down, so that actually the fire quantity will increase over time. Where I think it could be actually measured, and I think it will just be a linear increase because the burning is linear. Then and he measured mainly the angle, but he does not very clarify what is the relation with the angle to extinguish. Where I believe he should actually tell us under what condition it will extinguish and how long does it take to extinguish, with not just about the angle. And I think he lacked measurement on the fluctuating pressure, which is the most important part of the sound. And then he does not change amplitude while changing the frequency, which I think is very important because if you increase the frequency, actually the sound intensity increases. So in that, you need to decrease the amplitude to actually control the intensity with this equation right here. And for data analysis, he analyzed the scope of flame tilting, where he finds optimal extinguished frequency, which I think is very good. But I think he should compare with the case with the normal wing and to find the effect of the sound. So here are the discussion points we'll talk about. So first, we'll talk about the three elements of combustion, which is these three components. Then for a model assumption, so he assumed the constant fire intensity, but I believe the candle will burn over time. So I think it cannot simply model that, but this could be easily fixed in the theory. And about its experiment and control, so to say again, I think changing the amplitude, you need to change the amplitude while varying the frequency is very important because you want the same sound intensity. And also, determining the optimal fire extinguisher frequency is very important, which I'll talk about the limits with experimental results. Finally, we'll talk about the difference between sound and wind. Okay, so initial question, I thought you said the heat is missing. So can you elaborate more on why the heat is missing?
So when this air flow is produced, it's actually going towards this heat, and when it's cooling this it's cooling the candle, and because of that, our fire can be extinguished. However,
Can you show any experimental video? Yeah. Yeah, this one's okay. Yeah, this is good. This is good. Okay. Yeah. Okay. So you in your report you keep mentioning about the tilting of the flame angle, which I think is quite important. But this has no direct relation with the heat missing.
Okay, so for the tilting, I would like to clarify that I was actually saying that I actually even said that when the angle actually tilts to around 90 degrees is when our candle can extinguish potentially.
So what is the relation between the angle of tilt and extinguish? Does it mean a bigger angle means better extinguishing?
Yes, yes.
Okay. And so, but in my opinion, if you actually make the can you show you have a preliminary observation one, which you show different frequency, like a different frequency and a lot of video. Can you show that page?
By the way, I would like to clarify that at one point I did not understand your question, and actually, while we were changing the frequencies, we were varying the amplitudes as well, and I even showed this, I believe, on slide 16 or 17.
Oh yeah, can you just okay, we'll yeah. So but in my opinion, if you're that page, this is okay. So in my opinion, when the membrane is moving, it will blow the actual heat, blow the flame away, which the missing is the fuel, because it is away from the candle. Because if you blow the wind away from the candle, the flame has no fuel.
Yes, I actually want to say that not only that, but so it was actually both the cooling and the fuel, which in our case is the paraffin, which is blown away, and that is what actually causes our candle to extinguish.
And for a final component, so let's jump straight to the difference between sound and wind because it's easier. So you think there's no difference between the sound and wind?
No, I was saying that the sound is actually they provide oscillations, and because of these oscillations, we can provide the wind is produced.
So you have measured the speed of wind over sound, right?
The speed of wind over sound. We measured the speed of wind that was produced primarily because of the sound, because of oscillations. Yes.
If I have a sound and compare with, is there any difference?
I mean yes, because you're directly blowing wind, but you can actually even do an experiment where if you put your hand here and you start talking, you can feel that there is wind being produced as well.
Okay, yeah. So I think the most important of sound is sound is a longitudinal wave. So the pressure is actually fluctuating inside the sound. Do you agree?
Yes.
So this is actually, if the pressure is fluctuating, the third component, oxygen, will be missing. Do you agree with that? Yeah, because the pressure is fluctuating,
yes.
So when the pressure is at the lowest, the oxygen will also be at the lowest, correct?
I agree, yes.
Yeah, so I think the three elements will all be missing in a sound versus fire experiment. So yeah, I'm glad we clarified that. So so let's go on to our model assumption now. So you said it is a constant fire intensity. So have you had any video of the burning height over time?
No, but for our experiment where we were modeling with COMSOL, yes, we used the constant fire intensity.
And did you find it valid with the experiments? Did you tested the burning over time with the experiments?
We didn't test the burning. Well, we didn't explicitly mention it, but we noticed that as our wind current was increasing, it was getting easier to extinguish our flame.
Okay, can you go to the simulation in your console?
Yes.
Yeah, and can you slightly explain how the procedure of the simulation is there? Because I don't think it's quite clear.
Okay.
So what actually is your simulation?
So we have a speaker, right?
Yeah.
And it is producing sound. And in every single pressure plate, there is actually pressure that is being produced.
Yes.
And this is what will produce our wind. And as I said before, the red part is where our pressure is at its greatest, and the blue part is where this pressure as it is at its minus. And we could see in our model that this pressure actually varies over time.
Oh yeah, so it's also that this also proves the point of the pressure is high and low.
Yes,
Yeah.
I agree.
Okay, and so but you in your can this simulation predict the tilting? Because you said the extinguish is based on the tilting usually in the critical value. So can it predict the
yes, because this simulation precisely it is used to predict the velocity field at each point. And our velocity of the wind is what is going to cause what's going to impact our flame and extinguish it.
So do you have any data on the velocity to wind relation to the tilting angle? Do you have any data regarding that?
No, we do not.
Okay, but the thing is, have you any equations that actually like this simulation is based on? Is it based on like Navier-Stokes equation?
So we modeled our this through COMSOL, and COMSOL is these equations themselves. So we didn't actually.
So you're not very clear of the equation behind the actual simulation.
Well, it is obviously going to be equations of the variance of pressure.
Okay. Okay, it's fine. So I think you could actually improve on that. Maybe having a new model on the forced damped simple harmonic motion, because the speaker is like moving like this, and you can actually just calculate the wind hitting the fire and find relation. So now I would like to talk about with your data. So can you go to the data with different frequency and it's extinguished? Very frequency, yes.
So here the frequency of the extinguishing, right?
Yeah,
okay,
yeah.
Here. It is here, yes.
When will it extinguish?
You see these green parts over here? It is when our flame achieved an angle of around 90 degrees. So it is these green parts is when our flame is going to extinguish.
And is there any explanation on why 90 degrees is the extinguish critical threshold?
I mean, because the velocity of the convection flow is going to be directly normal to the
the wind is
velocity of the convection currents, yes.
And so the angle, so this angle is the deflection angle, right?
Yes.
So is it like always in the same angle, or it will like kind of move a little bit?
No, it moves a little bit, but as you can see here, we have red points and blue points. Our red points is because we actually tested this many times, and we used a blue point to find the average value of each testing.
Oh, okay. And so you have this 4 points as your extinguish, right?
As our extinguishing, yes.
Yes, and they are also defined as extinguished. Is there any difference on extinguished time?
Extinguished time.
So like.
Oh, okay, yes, evidently, because different frequencies are going to create different wind currents, and these different wind currents are going to extinguish our flame distinctly over time.
So are they same or different?
Different.
Okay, yeah. So this is a little improvement I think you could have. So if you could actually plot a frequency to the extinguished time graph,
yes,
we can actually get the efficiency of extinguish. Because if we want to actually extinguish a fire, we need the extinguish time to be lower. It will be better, right?
I agree with you, but our main point was to prove that the camera does it. But I agree with this one. Yes.
Yeah, it's fine. And so you mentioned, you clarified earlier. So you said you have controlled the sound intensity.
Yes.
So can you tell me the procedure on how you do it?
I mean, it is not very difficult. It was actually just adjusting the volume, and as we adjust our volume,
Okay. I think I believe you have actually have to control the sound intensity to ensure the most important parameter is controlled. So can you tell me again what are your main parameters?
Our parameters. So it was frequency, the amplitude, and the flame characteristics.
And can you show the amplitude to the flame tilting angle? Also, it would just have an increase, right?
Yes, it would just have an increase. As we were increasing our sound, the deflection angle just had a monotonous increases.
Okay, and I think this is very reasonable because as the sound intensity increases, it should just tilt more because of a stronger wind, right?
Yes, exactly.
And can you go back to a frequency one start?
Yes.
So this is like 0 to 2000. So
yes.
yeah, and it will just increase and decrease. Will it have anything? So after this limit, it will just all be the same.
Yeah, it would just as I said before, there would be no effects on the candle after this limit. Yes.
Oh, okay. And what's your final parameters when you're experimenting in your experiments?
So I mean, as I said before, I use the frequency, the amplitude, and the flame characteristics. And
Oh yeah, the distance. Yeah, the distance. Can you tell me the distance graph?
Yes, this is the deviation.
Oh, so the distance means the on the sides, right?
I mean, yes, but this just shows that depending on the distance,
Oh, yeah.
there are going to be different deviation angles.
Okay, thank you. So, and I think, okay, so, just to conclude my summary. So, I think the reporter could actually measure the sound profile of the speaker, because the sound profile of the speaker should be non-uniform, so that will prove the different extinguishability on a different position of the different candle. So, well, first we talk about the mechanism of the extinguishing. So, I talked about the three components of the combustion, which is a fuel, oxygen, and heat, where I believe the sound will get blown away, so the fuel will get cut off. And also, the sound is longitudinal wave, so the pressure will fluctuate. And if the reporter could have measured the fluctuating pressure to find the low pressure point, which cuts out the oxygen. And for model assumption, I think the console simulation needs to be more clarified on the procedures and the equations. And I think we could use force damping harmonic motion on the membranes hitting on a different fire. And then also we talk about experiments on its best extinguishability, where I believe the most important that you should measure is the extinguish time, which this also provides us another insight on the efficiency. Yes, thank you.
Thank you. Yes, please.
Thank you very much for this great presentation and discussion. First, I'd like to, as a reporter, can you please go to slide 5? And while you do that to the opponent, why do you think extinguish time is important?
Because as he explained, sometimes it will take a long time to extinguish, and sometimes it's very short. So I think it will be important on the efficiency of the extinguish.
Thank you very much. Slide 5, please. You have so you have measured power of the candle, or you have plotted a graph in terms of the power of the candle. How do you define that?
I've thought of it.
So this is the power there on the
Yes.
y-axis. How do you define that? Or what power is that?
I mean, it is the power of the candle.
Of the candle?
I don't understand.
Okay. Can you please go to slide 9?
Yes.
So here you say that the C value is 340 meters per second. Did you consider that around the flame the temperature is different?
Yeah. Well, we actually measured our room temperature, which was around.
But did you measure the flame temperature somehow?
I mean, yes, we had a thermocouple thermometer and we were able to measure different points.
And did you measure the temperature profile of the candle flame?
Yeah, I mean, yes, it's a thermocouple thermometer.
Okay.
I said yes.
Now some other clarification questions. Was your speaker calibrated?
No, it wasn't.
And you have mentioned that you used 2 speakers,
Right?
right? One phone and then.
Well, one speaker and one phone.
And do you have simulations for both of those in your console?
No, our simulation only comes from the speaker in the console.
And which one of the speakers did you use during your measurements?
Well, we used both. I mean,
Okay,
during our
thank you.
measurements.
Also, what is the basis of your console simulation? So, like, what equations? How does it work?
I mean, the velocity of the wind and then the variation of pressure of the speaker.
Okay, if you can go to slide 12, please. And okay, to the opponent, do you think that the acoustics of the room will influence the phenomenon?
I think it will have a minimal effect.
A minimum. Okay. Slide 12.
Yes, this slide.
Okay, so here, there are those limit spaces you have talked about, S1 and S2. Can you clarify that? How you define that space? What's the width of that?
I mean, we didn't define it, but
Okay, so
this is the explanation of it.
And also for slide 15, very quickly, how did you measure reflection angle? Did you measure the center of mass of the flame?
So actually, we had as I said, we had an equation with the arctangent where
Did you measure the reflection angle?
Yes or no?
Okay, thank you very much. name is Sunny, and I'm going to review problem number 12, sun versus fiber. So, about the overview of the report. Well, the phenomenon explanation, it was well needed because although the reporter explained the airflow and he proved it using different methods, I believe that in his measurements, the wind blowed out the candle instead of sound, and the major part of the discussion was about this. I will also show some my opinion later about this thing. For the theory, I lacked qualitative theory, nor the flame shape, nor the pressure wave or the airflow of the speaker was theoretically analyzed. So, and because of that, there were no comparison. For experiments, the reporter used a paraffin wax candle, and he used different frequencies, but he did not vary the fuel type, nor, for example, the state of matter of the fuel, which are some relevant parameters in our opinion. And also, there were no comparison because of the quantitative theory, or only qualitative trends were shown in the report. About, once again, the report, its strength that it was, the basics physics were very easy to understand, and the reporter had a working setup. However, as I mentioned previously, fuel type and fuel content was not considered, so maybe he could have used a gas burner, also not just candle, and also sound wave shape could be an interesting parameter to observe if the sound is a square wave, and also surrounding air parameters like air temperature or humidity are also relevant, I believe, for this problem. And when I say other measurement methods, I think of, for example, creating standing waves to blow out the candle, because here, once again, the wind was the main physics that blew out the candle, and in our opinion, it kind of violates the problem statement. And also, as I mentioned previously, there was no quantitative theory, which is a major lack of this problem. About the opposition, its strength, that was the opponent managed his time quite well, and also his presentation was great. He summarized the report very well. However, he could have stated more own opinions, and also we felt that there were too many topics discussed in the discussion, and they wasn't discussed in that great details. And also, he could have built a better structure as well. So, about the evaluation of the discussion, the first topic was about fire triangle, and here we agree with the opponent that the main cause of extinguishing is that the oxygen and also the fuel moves away from the heat, so it then will be extinguished. However, we think that about the angle, critical angle, and also heat in the problem. The reporter's opinion was that the critical angle is always 90 degrees. However, we can't really agree with that because the critical angle should have been measured, and it also depends on many relevant parameters of the flame. And yes, about the sound versus wind, this was the major part of the discussion. Once again, I would like to say that the problem statement says that the candle should have been blown out by sound, not wind, and but I kind of understand that the speaker creates some airflow, but some more effects of the sound should have been also investigated in our opinion. And about the burning of the candle, the opponent said that it burns slowly and kind of the flame decreases over time. However, we think that this is irrelevant because the measurements were done quickly. So thank you for your attention.
Thank you.
Okay. First of all, I would like to thank both the opponent and the reviewer for their opinions. And the reason I talk so much about the wind, because it is not actually the sound that is going to extinguish fire, but the oscillating waves produced from the sound, which produce wind, and that is what is going to extinguish the fire. And the most important parameter in this was most definitely of this situation was definitely the velocity of the airflow produced, because it is the airflow that would extinguish our candle. And in general, I would like to say that yes, I agree with the reviewer that the burning over time was relevant. And however, I would also like to say that the pressure and the wind current were also as important, even though the reviewer may not agree with me on this point for our problem. So overall, thank you very much for listening to my presentation, and this is everything. Thank you.
Now the jury questions. Who wants to go first? Please.
A question to the opponent. Due to the oscillating wind speed, do you think that resonance effect will be dealt with the problem and should be a cause to extinguish the flame?
I think maybe I'm not. Can we talk about what part of the resonance?
I think you get movement of the angle of the flame, and you got a oscillating wind speed. Are there any resonance effects?
I think it's possible due to the natural frequency of the fire.
Maybe to the reviewer, what do you think?
Yes, I
So
would agree.
you.
Sorry.
Okay. No. Yeah, you can answer.
So I would partially agree with what you said. That's also why I asked about the room acoustics, because it may have some effects with that as well.
Thank you.
Yes, please.
It's related. To the opponent, you say that I can model as a simple harmonic motion, forced and damped. Why?
Because I think it's something with the membrane, because you can imagine the membrane is actually like pushing wind. So I think it's possible that the flame is like, if we measure the angle over time, I think we could get more idea on the simple harmonic motion of the tilting angle.
It will be a simple harmonic motion.
What?
But will be a simple harmonic motion.
If his fire did move with the membrane, yes.
Thank you. Questions? Okay. I have a question to the reporter. Please explain to me like what physics is inside the console simulations.
Okay, so as I said, there is a variation of the pressure. So there were equations that variated our pressure, and this pressure, it was actually related to the velocity of the air, and this is how we managed to calculate the velocity of the speed.
Okay, thank you.
Maybe just a clarifying quick question on this. Like, what did you input to the simulation?
Well, we input our speaker, then we input that our.
Yes, you can answer the question about console.
Our aim of the simulation is to find out the pressure at every point behind in front of the dynamic, in front of the speaker. So we calculate in there the atmospheric absorbing the energy loss to calculate the pressure at every point in front of the speaker, and this pressure can give us to the velocity field to find the velocity at every point of the at this space. And so by this formula, which he shown here, the averaging of the every velocity at every point can give us to the average value of the air flow, which also give us to the deviation angle.
Thank you. Any more questions?
We've got some time.
Yes, please.
To the review, what about, you were talking about standing wave.
Yes.
Can you explain, can they play a role to extinguish the flame here?
Well, I thought of configuration where, for example, the flame at the candlestick is moved by the standing wave to an extent that it kind of also extinguishes.
It's about the room acoustics, we're talking about wavelength of 10 meters, what I got in mind.
Well, I'm not quite sure about that.
I will rephrase the question. Like, are we talking about a normal room or like a very small room or even a box? Maybe.
Yeah, maybe not in a very small room, but yeah. Or maybe if other like some special type of sound is used, for example, ultrasound or something like that, maybe there.
Yes, Mark.
For the opponent, you mentioned that all the three components that the flame needs are relevant. That the fact that they are missing, that it is relevant, but do you think that they contribute the same amount or to this task?
I don't think, like some I believe they are smaller, some are bigger.
Which one?
If I were to say, I believe the pressure is the least, because I think because if the sound frequency is so fast, the fluctuating is so fast, so I don't think the oxygen will be there.
Yeah, I think that's it. Yeah, let's move on to grading. Okay. So you prefer that I run from myself that way, yeah? Okay. First, the grades for the report. 3, 3, 4, 3, and 3. Grades for the opposition. 6, 7, 7, 6, and 5. And grades for the review. 8, 7, 7, 7, 7. Okay, thank you very much. So let's start with the low rate of review. So we do the report, so we end up with a higher grade in the end. We have 4 threes who wants to say something. Maybe you can
I think you have. Okay, I think have some interesting ideas, like actually images, and the console is a good idea, but you get a little confusing explaining to us how you made this a method, a quantitative method of this problem. And so in my partial grade was 1.2, 1.2, and then I go down to 3. But I like some qualitative ideas of your problem, but the quantitative wasn't too good.
Thank you. On the higher end.
Yes,
So
so
Maroš?
I think I've graded similarly as my colleagues, but I value the number of experiments we did on the number of parameters, the frequency, amplitude, big length, the stuff you mentioned. So maybe that's why I did 1 point higher.
Okay, thank you. Yeah, I'll just give you a brief comment from myself as well, because I was in between 3 and 4, and to my previous grades I decided to go on 3. But the main reason of this grade is that, it is like you did not have like any theoretical model in your presentation, so in the report part it will just, according to the score sheet, you will not be able to pick up many points. But presenting like you were great, though, is like how you presented whatever you had done, like you presented it really well. But you had some experiments, data, and presentation skills were okay. But however, in the discussion, I was not able to give you lots of grades as well, because you were not that active with the opponent, and yeah, like the discussion was not very good from your part. So that's how I ended up this grade. And now the opponent, we have 5 for Otmar.
Yes. At first, I think you did a quite well job to find the strengths, and I had unfortunately to say the weaknesses of the report, and therefore your job wasn't so easy to do. But nevertheless, you had, in my opinion, go further into his presentation, maybe ask for the diagrams and the measurements through different wick length and diameters of the candle, maybe other flames. It's just a small flame, it hadn't to be a candle. Maybe ask for that, maybe to ask for improvements, the reporter, or maybe have own opinions. And then that was my question due to resonance. The Schlieren optics, I think that's a good idea to visualize the movement of the candle, and then you can see the oscillations, and at least you had asked for some resonance effects and maybe discuss them.
Okay, thank you. For the high grade of opponent, we have 2 7s. I'll also let it talk to Maroš, maybe if you can say.
So high grade for the opponent, right?
Yeah.
Okay. I like your approach. I like especially the first half of the discussion, because I agreed with some of the points you made. Especially, I wrote it down that reporter did not connect the flame angle with actual flame extinguishment. I liked that part. And yeah, I graded you highly in the discussion, mainly in discussion. But yeah.
Okay. Thank you. For the review, we have 4 7s and an 8 from me. Maybe Kashki, you have not said. Yeah, you can give a brief comment.
Okay, for me the review was one of the best highlights that you've done. You've really covered everything. Where I found out from starting with the opposition, asking number of questions to maybe you have asked less number of questions to opposition, but yes, the question distribution was one of the aspects where I thought basically should have given more questions to opposition to just clarify. But yeah, still I thought it was a good number of questions that were asked and a good review of the report, a proper analysis of the opposition basically, and that's how I gave a grading like 1.5, 1.5, 1.5, 1.5, that turns up to 7.
Okay, thank you very much. And yeah, I gave you an 8. So basically, I liked like everything was very good for me. So I'll tell you exactly. So starting from your clarifying questions, even though like the opposition was good in my opinion, like you made me to bring in some new things that I have not heard during the opposition speech, and like you were very clear about it. So like your review in overall gave me a sum up like what you should have done. And yeah, your review of the report was also almost perfect. Discussion analysis good. One thing that restrained me for like even going up was review of opposition. It was basically I was looking at the clock because I was keeping the time as well. You just for the opposition you only spent 20 seconds. Even but I still did not give you. I gave you like an average grade there because of the fact that you said 2 sentences and like both for both 2 sentences I completely agreed. And if you just spend some more time on that, so it would have been more balanced. It would fit. Good, I guess. Yep. So if the teams would like to ask the jurors for any particular partial grades, you are welcome to. If not, yeah, we can ask questions during break or discuss it. Yeah, thank you very much. Okay. This is a group of 4, so please be at in 8 minutes here, so that we can start at 3:20 sharp. And teams, please switch the role so you know.